In 1958, two chemists published an equation describing how metal alloys split into separate phases when they cool. In 1971, an economist pushed pennies and dimes around a checkerboard and accidentally proved that total segregation can emerge from perfectly tolerant people. In 2007, a physicist whose father survived the Holocaust fed a Yugoslav census into both of those equations and produced a map. The map showed in red exactly where the ethnic killing would happen. It was drawn 4 years before the first shot was fired. The correlation with actual massacres was 90%. Those three facts are the same story, and the story does not end in Yugoslavia. It runs through the creation of Switzerland's youngest canton, through a Soviet dissident's son who predicted American collapse a decade before it began, through a proposal for Syria that could have saved 500,000 lives and was never read by anyone who could act on it. By the end of tonight, you will understand why the fault lines beneath the country you live in are already drawn, and why the people whose job it is to see them have not looked. Settle in for this one. If you are not subscribed, now is a good time, and if you want more of this kind of thing across physics, history, collapse, and the math behind all of it, the Patreon is where those deeper dives live. Stay to the end, because the last 20 minutes of this script are the part that will not leave you alone. Let's start where it started. In 1991, a census was taken in Yugoslavia. It was the last one. 14 million people across 6 republics filled out forms listing their nationality, their language, their religion: Serb, Croat, Bosniak, Slovene, Macedonian, Montenegrin, Albanian. 14 million data points, sorted into columns, filed in government offices in Belgrade. Nobody thought of it as a death map. 4 years later, 100,000 of those people were dead. 2 million were refugees. 8,000 men and boys were executed in a single week in a town called Srebrenica, which had been declared a United Nations safe area. The worst massacre on European soil since the Second World War. And the question that historians and political scientists and foreign policy analysts have spent 3 decades trying to answer is the obvious one. Why? Why did Yugoslavia break? Why did the killing happen where it happened? Why Srebrenica and not Ljubljana? Why eastern Bosnia and not the Dalmatian coast? Why those borders? Why those fault lines? 212 explanations have been proposed for the collapse of the Roman Empire. That is not a metaphor. That is an actual count, compiled by a German historian named Alexander de Mandit in 1984. 212 different causes, from lead poisoning to moral decay to deforestation to the adoption of Christianity. And the number of proposed explanations for Yugoslavia is heading in the same direction. Nationalism, Milosevic, the death of Tito, economic collapse, ancient ethnic hatreds, the failure of communism, Western indifference. Each explanation confident, each explanation incomplete, each one treating the fracture as a political event that required political analysis. But in 2007, a physicist in Cambridge, Massachusetts, took that 1991 census, the one taken before the wars began, and ran it through an equation that had nothing to do with politics, nothing to do with nationalism or ideology or Slobodan Milosevic or ancient hatreds. The equation was originally designed to describe how oil separates from water, and the model predicted from census data alone exactly where the killing would happen. Not approximately, not loosely. The correlation between the model's predicted violence map and the actual locations of major fights and massacres was 90%. And when they ran the same model on India, Using the 2001 census, the correlation was 99.8%. Not a rough sketch, a near-perfect overlay. The places where the model said violence would erupt and the places where violence actually erupted were, for all practical purposes, the same map. The physicist's name was Yaneer Bar-Yam. He was the founding president of the New England Complex Systems Institute, and the equation he used was not from political science. It was not from history. It was not from sociology or international relations or any of the disciplines that are supposed to explain why empires fragment. It was from condensed matter physics, the specific branch of physics that describes how mixtures of incompatible materials phase separate over time, how oil and water, if you shake them together, will always find their way back apart. And the implication of what Bar-Yam found is the kind of thing that should have reshaped how every government on Earth thinks about borders, ethnic conflict, and the stability of nations. It should have been front-page news. It should have been discussed in the United Nations General Assembly, in NATO strategic briefings, in every graduate seminar on international relations from Cambridge to Geneva. It was published in Science, one of the two most prestigious scientific journals on the planet. September 14th, 2007. Volume 317, Issue 5844, pages 1540 through 1544. The authors were May Lim, Richard Metzler, and Yaneer Bar-Yam. The title was Global Pattern Formation and Ethnic/Cultural Violence. And then, for the most part, nothing happened. Political scientists ignored it because it came from physicists. Physicists largely ignored it because it was about politics. The people who make decisions about borders and refugees and peacekeeping operations ignored it because nobody forwarded it to them, and nobody forwarded it to them because it fell into a disciplinary no man's land where no one felt ownership. I spent an unreasonable amount of time reading everything connected to this paper. The paper itself, the follow-up papers, the critiques, the rebuttals, the parallel work by Peter Turchin on mathematical models of imperial collapse, the older theoretical framework, going back to Thomas Schelling's checkerboard models of segregation in 1971, the Swiss data, the Indian data, the applications to Syria and Yemen and Central Asia. And what I found is not just a story about one model or one paper. It is a story about a pattern that has been hiding in plain sight for decades, possibly centuries, and about what happens when someone finally writes down the equation that describes it. Because here is the part that should genuinely unsettle you. The model does not care about your politics. It does not care about ideology. It does not care about leaders, about constitutions, about historical grievances, about international alliances, about economic conditions. It cares about one thing: how groups of people are spatially distributed on a map. That is it. Give the model a census and it will draw the fault lines. Give it a census taken before the violence and it will draw the fault lines that the violence will follow. Not because the model is prophetic, but because the fault lines are not political. They are geometric. They are a property of the spatial distribution of populations. They are physics. And if you are sitting there thinking that this is interesting but not personally relevant, consider this. The model can be run on any country with census data, any country with mixed populations, any country where groups of people who identify differently from each other are distributed across a shared territory in patches of a certain size. The model has been run on the country you live in, and what it found is something that nobody in a position of power wants to discuss publicly. Because the same equation that predicted the Bosnian War, the same equation that mapped the Indian communal riots, the same equation that retroactively explained why Switzerland is peaceful, produces output when you feed it the demographics of the modern world. And that output is not reassuring. But I am getting ahead of myself. Before we can see where the fault lines are, you need to understand what creates them. And that means you need to understand something about how oil separates from water and why it matters that human beings, when given a choice, behave exactly the same way. In 1971, an economist named Thomas Schelling sat down at a table and started pushing pennies and dimes around a checkerboard. Schelling was not a physicist. He was not a sociologist. He was a game theorist who had spent the previous decade advising the United States government on nuclear strategy during the Cold War. His most famous book, The Strategy of Conflict, published in 1960, had used game theory to analyze the nuclear standoff between the United States and the Soviet Union. Multiple historians have argued that Schelling's work is one of the reasons the Cold War never became a hot one. In 2005, he won the Nobel Prize in Economics. But on this particular day in 1971, Schelling was not thinking about nuclear war. He was thinking about neighborhoods. Specifically, he was thinking about why American cities were so profoundly segregated by race, even in places where nobody had passed a law requiring segregation, even in places where surveys showed that most residents were perfectly comfortable living next to someone of a different race. The model he built was absurdly simple. Take a checkerboard. Place pennies and dimes on it randomly, representing two different groups. Each piece has a single preference. It does not demand to be surrounded by its own kind. It does not hate the other kind. It simply prefers not to be in the extreme minority in its immediate neighborhood. A penny that is completely surrounded by dimes will try to move. A penny that has at least a few other pennies nearby will stay put. That is the entire model. One rule, one mild, reasonable, almost embarrassingly moderate preference. And when Schelling ran the simulation, what emerged was total segregation. Not partial clustering, not mild self-sorting, complete ghetto-level separation. The pennies ended up in one area of the board, the dimes in another, with a sharp boundary between them. Every single time. The result was so counterintuitive that it changed the field. The Journal of Mathematical Sociology published it in their very first volume. The finding was this: you do not need racists to produce racism. You do not need bigots to produce segregation. You do not need anyone to prefer homogeneity. All you need is a large number of individuals, each with a mild preference not to be a minority in their immediate surroundings, and the mathematics of the situation will produce extreme separation automatically. It is an emergent property. It arises from the interactions, not from the intentions. No one chose it. No one planned it. No one even wanted it. But the math made it inevitable. I want you to hold that finding in your mind, because it is the foundation of everything that follows. And what follows gets considerably worse. What Schelling demonstrated with pennies on a checkerboard, physics had already demonstrated with atoms in a metal. There is a phenomenon in condensed matter physics called spinodal decomposition. Take two metals that do not mix well. Alloy them together by heating them to a high temperature, where they dissolve into each other. Then cool them down. As the temperature drops, the two metals will separate, not all at once, in patches. Small clusters of one metal will appear, surrounded by the other metal, and those patches will grow, slowly at first, then faster. The clusters coalesce, merge, expand, the boundaries between them sharpen. And the rate at which this happens follows a precise mathematical law called the Lifshitz-Slyozov coarsening equation. The patches grow as the cube root of time. This is not approximate, it is exact. And it is universal, meaning it applies to every mixture of immiscible materials regardless of what those materials are. Oil and water, two metals in an alloy, two groups of people in a country. The mathematics is identical. And the reason it is identical is that the mathematics does not care what the agents are. It only cares about one thing. Do the agents prefer to be near similar agents? If yes, phase separation occurs. If the preference is strong and the system is given enough time, the separation is total. The pennies go to one side of the board. The oil rises to the top. The Serbs end up in Republika Srpska, and the Bosniaks end up in the Federation. Not because of ancient hatreds, not because of geometry. That is what Schelling found in 1971. That is what physicists had known about alloy systems since the 1950s. And that is what Yaneer Bar-Yam formalized in 2007, when he took the mathematics of phase separation and applied it to the census data of Yugoslavia and India. But the formalization did something that Schelling never did. It made a specific quantitative prediction about where violence occurs. And that prediction is what changes this from an elegant theoretical curiosity into something that should keep you up at night. Here is what Bar-Yam's model says. And I need you to understand it precisely, because the precision is the point. Take a map, divide it into small cells, assign each cell a population type based on census data: Serb, Croat, Bosniak, Hindu, Muslim, French-speaking, German-speaking. It does not matter what the categories are. What matters is that there are categories and that the people in those categories are distributed across the territory in some pattern. Now zoom out, look at any given point on the map, and measure the local composition of the population in a circle around that point. How big is the circle? That is the key variable. Bar-Yam calls it the characteristic length. It is measured in kilometers, and the characteristic length that matters, the one where the math goes wrong, is between roughly 20 and 60 kilometers. In Yugoslavia, the critical range was 18 to 60 kilometers. In India, it extended up to about 100. The exact number varies by region, but the range is strikingly consistent. At that scale, ask a simple question. In the circle around this point, does one group dominate? Or is it mixed? If one group dominates overwhelmingly, meaning their patch is much larger than the characteristic length, the model predicts peace. If the groups are thoroughly mixed at a very fine grain, meaning no group forms a patch larger than a few kilometers, the model also predicts peace. But if the patches are at the characteristic length, if one group forms a cluster large enough to feel like it owns the public space, but small enough to be surrounded by and threatened by another group, the model predicts violence. Think about what that means. There are exactly 3 regimes. Fully mixed populations are peaceful because no single group perceives ownership of public space. Everybody is a minority everywhere, so multicultural norms emerge. Fully separated populations are peaceful because each group has uncontested control of its own territory. The boundaries are clear, the patches are large, and there is no ambiguity about whose space is whose. But in the middle, at that characteristic length of 20 to 60 kilometers, you get something else entirely. You get patches big enough for a group to think, this is ours, but small enough to be surrounded by another group that thinks the same thing about the adjacent territory. That is the violence zone. That is where the killing happens, every time. And the model does not just identify this zone abstractly. It draws it on a map. Here is what Bar-Yam and his team did with the Yugoslav census. They took the 1991 population data, the census taken before the war started. They converted each municipality into an agent-based representation. where every cell on the map was assigned a nationality: Serb, Croat, Bosniak, Slovene, Macedonian, Albanian, and so on. Then they applied a wavelet filter at the characteristic length. At each point on the map, the filter measured the local composition of the population in a circle of that diameter, and flagged locations where one group's share crossed a threshold large enough to feel like a local majority, but in a patch small enough to be contested by neighbors. The output was a heat map. Red areas indicated high predicted violence. The brighter the red, the more the spatial mathematics suggested that location was primed for conflict. Yellow dots marked the cities where major fights and massacres had actually been reported during the wars. The correlation was 0.89, 90% overlap between the predicted violence map and the actual violence map. And this was not a post hoc fit. The model had exactly one free parameter: the characteristic length. It used no information about politics, no information about Milosevic or Tudjman or Karadzic, no information about the JNA or the VRS or NATO, no information about the economy, the constitution, the history of World War II grievances, the Chetnik-Ustasha divide, or any of the factors that fill entire libraries of analysis about why Yugoslavia collapsed. Census data, one equation, 90% accuracy. And there is something else the model predicted that no political analysis had. It predicted where violence would not occur. Slovenia, which declared independence in June of 1991 and fought a 10-day war that killed 66 people, shows up on the model as a region of large, homogeneous patches with clear administrative boundaries. The model predicts peace. And that is what happened. Slovenia's exit was the quietest of all the Yugoslav republics. Macedonia, which seceded without a war at all, shows a similar pattern in the model. The administrative boundaries were well aligned with the ethnic boundaries. The model says no violence, and there was none, or effectively none compared to Bosnia and Croatia. But eastern Bosnia, the Drina Valley, the Krajina in Croatia, Vojvodina, Kosovo, every one of these regions appears as a bright red zone on the prediction map. Patches at the characteristic length, groups interleaved, no clear boundary, exactly the configuration that the mathematics of phase separation identifies as unstable. Srebrenica was a Bosniak enclave inside Serb majority territory, a patch at exactly the wrong size, large enough for the Bosniak community to feel that it was their town, small enough to be entirely surrounded by Serb-controlled territory. The model does not know the name Ratko Mladic. It does not know that Dutch peacekeepers were stationed there under a UN mandate that gave them no authority to fire. It does not know that 8,372 men and boys would be separated from their families and executed over the course of 5 days in July 1995. It does not need to know any of that. The census data from 4 years earlier was sufficient. The mathematics identified Srebrenica as a point of maximum instability. And I want you to sit with that for a moment, because the implication is profoundly uncomfortable. It suggests that the specific political events we study, the speeches, the propaganda, the decisions made in smoke-filled rooms in Belgrade and Zagreb and Palais were not the causes of the violence. They were the mechanisms. The fault lines were already there. They were drawn into the census before the first shot was fired. The politics filled the cracks that geometry had already created. Now, this is where a certain kind of person will push back. They will say that correlation is not causation. They will say that the model is descriptive, not explanatory. They will say that census patterns themselves are the product of politics and history, so claiming that geometry caused the violence is circular. And these are reasonable objections. I want to address them honestly, because the audience for this channel deserves intellectual honesty, not rhetorical tricks. The most serious academic critique came from Niels Weidmann, then at the Peace Research Institute Oslo, and Monica Duffy-Toft at the Harvard Kennedy School. In 2010, they published a paper in Conflict Management and Peace Science titled Promises and Pitfalls in the Spatial Prediction of Ethnic Violence, a comment. Their argument was that Bar-Yam's correlations were partly inflated by methodological choices, specifically by the way the wavelet filter's length scale was selected and by the spatial autocorrelation of violence data, meaning that violence clusters geographically. So any model that identifies geographic clusters will show high correlation whether or not it has identified the right mechanism. This is a real critique, and it would be dishonest to pretend it was not made. But here is what happened next. Bar-Yam's team responded. Dion Harmon, May Lim, and Yaneer Bar-Yam published a rebuttal in the same journal, same volume, same year. Advanced Mathematical Science of Ethnic Violence, Conflict Management and Peace Science, Volume 27, Issue 2, pages 177 through 194, 2010. They reran the analysis with additional statistical controls. The results held, and they pointed out something that even Weidmann and Toft had conceded in their own critique. Homogeneous populations are not susceptible to violence. The core prediction of the model, that fully mixed and fully separated populations are peaceful, while intermediate-sized patches are violent, was not disputed by the critics. The disagreement was about the precision of the spatial prediction, not about the fundamental mechanism. So where does that leave us? It leaves us with a model that even its critics agree captures a real phenomenon, and that its proponents have validated at correlation levels between 0.89 and 0.998 across two very different countries with very different histories, different religions, different languages, and different political systems. Yugoslavia and India share almost nothing in common except this. Both had populations distributed in patches at the characteristic length, and both experienced violence at exactly those locations. But Bar-Yam did not stop with historical prediction, because if the model is right, if violence really is a function of spatial geometry rather than politics, then the model should be able to explain something even harder. It should be able to explain why some countries that have every reason to tear themselves apart do not. And that is exactly what happened when they turned the model on Switzerland. Switzerland has 4 national languages: German, French, Italian, and Romansh. It has 2 major religious traditions, Protestant and Catholic. These divisions overlap imperfectly with each other and with cantonal boundaries, creating a patchwork of communities that, on paper, looks like a recipe for exactly the kind of fragmentation that destroyed Yugoslavia. Switzerland's population density is comparable. Its history includes periods of genuine religious conflict, including the Sonderbund War of 1847. By every measure that political scientists traditionally use to predict instability, including ethnic fractionalization, linguistic diversity, and religious heterogeneity, Switzerland should be one of the most volatile countries in Europe. And yet, Switzerland is one of the most peaceful and stable nations on earth. It has not fought a war since 1847. Its democratic institutions are older than those of most European states. Its per capita GDP is among the highest in the world. The standard explanation for this is that Swiss political institutions, particularly the system of direct democracy and cantonal autonomy, manage diversity effectively. And that is true. But Bar-Yam's model offers a much more specific and much more testable explanation. In 2014, a team led by Alex Rutherford with Dion Harmon, Justin Werfel, Alexander Gard-Murray, Yaneer Bar-Yam, Andreas Gross, Ramon Zulvi-Brunet, and Yaneer Bar-Yam published a paper in PLOS 1, Volume 9, Issue 5, Article number E95660, May 21st, 2014. The title was Good Fences: The Importance of Setting Boundaries for Peaceful Coexistence. They applied the Bar-Yam model to Switzerland using the 2000 census data. And what they found is this. At a characteristic length of 24 kilometers, the model calculates a propensity to violence of 0.57 for Switzerland without political boundaries. That means if you took Switzerland's population distribution and ignored the cantonal borders entirely, the model says there is a 57% chance of violence at locations where patches are at the characteristic length. 57%. That is not peace. That is a coin flip away from Yugoslavia. But when you add the cantonal borders back in, the propensity drops to 0.20. 20%. The borders did not change the demographic distribution. They did not move the people. They simply drew lines on the map that separated the patches from each other, and that was enough. The mathematics of phase separation says that clear boundaries between patches eliminate the contested zone. If a group knows where its territory ends and another group's begins, the ambiguity that drives violence disappears. And there was one exception, one place in Switzerland where the model said the borders were not drawn correctly, where the boundaries were porous, where one group's patch leaked into another group's territory without a clear dividing line. The Jura region in the northwest corner of the country, where French-speaking Catholics had been assigned to the German-speaking Protestant canton of Bern in 1815 at the Congress of Vienna as part of the political reshuffling that followed Napoleon's defeat. The model said this region was unstable, and the model was right. Starting in the late 1940s, French-speaking residents of the Jura began agitating for separation from Bern. A separatist movement called the Rassemblement Jurassien formed in 1959. A youth wing called the Groupe Belia formed in 1962. They did not just write petitions. There were protests. There were bombings. In 1972, Jura militants destroyed an army munitions depot. There were attacks in Bern and Courtelary. Bars in the Jura were divided into separatist bars and loyalist bars. The canton of Bern secretly distributed over 430,000 Swiss francs to loyalist groups between 1974 and 1982 to influence referendum results, a scandal known as the Black Boxes Affair that was not revealed until 1984. In 1974, a referendum was held. The 7 districts of the Jura voted on whether to form a new canton. The 3 northern districts, which were predominantly French-speaking and Catholic, voted yes. The 3 southern districts, which were more mixed, voted to stay with Bern. A third round of voting in the border municipalities saw each commune choose its side. On September 24, 1978, Swiss voters nationwide approved the creation of the canton of Jura by 82.3%. On January 1, 1979, the 26th canton of Switzerland was officially established. The model, using census data, predicted that the Jura was the single most unstable region in Switzerland, and the Jura is the only region in Switzerland where political violence occurred in the 20th century, and it is the only region where the political map was actually redrawn. The correlation between the model's prediction and reality in Switzerland was above 0.95. Think about what that means. A model built from the physics of oil and water separation, using nothing but census data and one equation, retroactively identified the single point of instability in one of the most stable countries on Earth. It did not identify Geneva, where French speakers border Italian speakers. It did not identify the Graubünden, where 3 languages overlap. It identified the Jura, because the Jura was the one place where the cantonal borders did not align with the population boundaries at the characteristic length. Switzerland is not peaceful because Swiss people are more civilized. Switzerland is not peaceful because direct democracy resolves conflicts. Switzerland is peaceful because, either by accident or by institutional evolution over centuries, its cantonal borders were drawn at exactly the right scale to separate population patches and eliminate the contested zone. Everywhere in Switzerland where the borders are correctly drawn, the model predicts peace, and there is peace. The one place where the borders were wrong, the model predicted violence, and there was violence, and the violence did not stop until the borders were corrected. This is the finding that should have changed how governments think about borders, and it was published in 2014 in PLO S1, and it did not change anything. I need to pause here and make sure something lands properly, because when I say the model predicted violence in India with a correlation of 99.8%, that number sounds abstract. It sounds like a statistic, and statistics are easy to hear and hard to feel. So let me tell you what that number actually represents. The partition of India in 1947 killed somewhere between 200,000 and 2 million people. The range is that wide because nobody was counting. 14 to 16 million people were displaced in one of the largest forced migrations in human history. Entire train cars arrived at stations on both sides of the new border filled with corpses. Mobs of Hindus attacked Muslim neighborhoods. Mobs of Muslims attacked Hindu neighborhoods. Women were abducted, raped, and murdered in numbers that were never accurately recorded because recording them would have required admitting they happened at scale. The British drew a line through the subcontinent in 5 weeks, using census maps and a lawyer named Cyril Radcliffe, who had never been to India before he arrived to partition it. Radcliffe later said he was given inadequate information and inadequate time, and that he was haunted by the consequences for the rest of his life. He refused to accept his fee of £2,000 and never returned to India. The 2001 census of India, 54 years after partition, still shows the scars. The population distribution along the India-Pakistan border, in Kashmir, in parts of Gujarat, in the communal hotspots of Uttar Pradesh and Bihar, still contains patches at the characteristic length. And when Bar-Yam's team applied the model to this census data, comparing predicted violent zones to reported communal riots and incidents of ethnic and religious violence, the correlation was 0.998, 99.8%. That is not a metaphor. That is a number. It means that if you took the census data with zero knowledge of Indian politics, zero knowledge of the BJP or the Congress Party or the Babri Masjid demolition or the Gujarat riots of 2002 or the Kashmir insurgency or the history of Hindu-Muslim tensions going back centuries, and you ran a physics equation designed for alloy phase separation, you would produce a map that is virtually identical to the map of actual violence. And the reason this is disturbing, rather than merely interesting, is that it suggests something that a lot of people do not want to hear. It suggests that the violence is not, in any meaningful sense, caused by the political events that precede it. The political events are the spark, but the fuel, the tinder, the geometry of the fire, was there long before anyone struck a match. The census map is the fire map. The politics just determines the timing. I want to come back to the physics now, because there is a deeper layer underneath the model that makes the finding even more unsettling. Bar-Yam's model is built on 3 ingredients. First, an agent lattice, a grid of cells each assigned a type from census data. Second, a dynamic. Each agent, each cell, has a preference for being near agents of the same type. This is the Schelling preference, the same mild, do not want to be in the extreme minority preference that produces total segregation on a checkerboard. Third, a filter, a wavelet applied at the characteristic length that identifies locations where one group's local share crosses a threshold large enough to feel ownership, small enough to be contested. But the dynamic, the way agents self-sort over time, is not an abstract rule that Bar-Yam invented. It maps directly onto an equation from physics called the Cahn-Hilliard equation. This equation was published by John Cahn and John Hilliard in 1958 in the Journal of Chemical Physics. It describes how a homogeneous mixture of two materials, cooled below its critical temperature, will spontaneously separate into distinct phases. The phases start as tiny fluctuations, random local concentrations of one material over the other. These fluctuations grow, they coalesce, they form larger and larger domains. And the domains grow according to a precise power law discovered by Ilya Lifshitz and Vitaly Slyozov in 1961. The average domain size grows as the cube root of time. That is a very specific mathematical statement. It means that if the average patch size is 10 kilometers after 100 years, it will be roughly 21.5 kilometers after 1,000 years. The rate of separation is universal. It does not depend on whether the agents are atoms of copper and zinc in a brass alloy, or molecules of fat and water in a salad dressing, or Serbs and Croats in a Yugoslav census. The mathematics is identical, because the mathematics does not care about the nature of the agents. It cares only about whether they prefer to be near similar agents. If they do, phase separation occurs. The rest is just details. And here is where I need to introduce the word that makes physicists uncomfortable when it is applied to human populations. The word is universal. In physics, universality means that a phenomenon obeys the same mathematical laws, regardless of the specific details of the system. The critical exponents of a phase transition are the same whether you are looking at a magnet, a liquid-gas transition, or a binary alloy. The details differ. The math is the same. And when Bar-Yam applied phase separation mathematics to human populations and found that the same equation with the same functional form predicted violence at the same characteristic length scales across two completely different countries on two different continents, with two different histories and two different sets of ethnic categories. He was demonstrating universality, not as a metaphor, as a measured empirical fact. The implications of this are staggering, and almost nobody discusses them, because if the phase separation of human populations is genuinely universal, if it obeys the same mathematical laws as the phase separation of immiscible fluids, then several things follow that are very difficult to accept. First, it means that the specific identities of the groups do not matter. Serb and Croat, Hindu and Muslim, French and German, Hutu and Tutsi. The labels are interchangeable. The model does not even know what the labels mean. It only knows that there are two or more types and that they are distributed in a certain spatial pattern. This means that the violence is not caused by any specific cultural incompatibility between groups. It is caused by geometry, by the size of the patches, by the distance between the patches and the boundaries. Second, it means that the violence is not a failure of civilization. It is not a reversion to primitive tribal instincts. It is not a moral failing. It is a phase transition, a thermodynamic process operating on a social system. And just as you cannot prevent oil from separating from water by lecturing the oil molecules about tolerance, you cannot prevent ethnic violence by lecturing populations about coexistence. Not if the spatial geometry is in the critical range. The lectures might delay the transition. They might reduce its severity at the margins. But as long as the patches exist at the characteristic length, the system is thermodynamically unstable. Something will trigger the transition eventually. If not Milosevic, then someone else. If not the death of Tito, then some other perturbation. The model says the system was a loaded gun. The politics just pulled the trigger. Third, and this is the one that I personally find most difficult, it means that forced integration can make things worse. The model predicts a non-monotonic relationship between mixing and violence. If you take a partially separated population and push it toward more mixing without pushing all the way to full integration, you can move the population through the violence-prone regime. You can take a situation that was tense but stable and make it lethal. This is not a theoretical prediction. This is arguably what happened in Yugoslavia itself, where Tito's policies of enforced brotherhood and unity moved populations into exactly the intermediate mixing regime that the model identifies as maximally dangerous. When the political pressure that maintained the mixing was removed after Tito's death in 1980, the system began to phase separate, and it separated violently, because that is what the mathematics says it must do. I want to tell you about the man behind this model now, because his story is not incidental to the science. It is connected to it in ways that he would probably not describe publicly, but that illuminate why this particular physicist spent years studying the mathematics of ethnic violence. Yaneer Bar-Yam was born on August 29, 1959, at Beth Israel Hospital in Boston, Massachusetts. His parents were Israeli immigrants. His father, Zvife Bar-Yam, was born in Krakow, Poland. Zvife lived through the events chronicled in the book and film Schindler's List. He was a Holocaust survivor. He emigrated to Israel, where he met Yaneer's mother, Miriam. They came to the United States so that Zvife could study physics, first at the Carnegie Institute of Technology, now Carnegie Mellon University, and then at MIT. ZVI became a groundbreaking high-energy particle physicist. Miriam, educated at Harvard, became an authority on child developmental psychology, specializing in moral development. Yaneer received his bachelor's degree in physics from MIT in 1978, at the age of 18 or 19. His undergraduate thesis was on radio interferometry and observations of Saturn. He received his PhD from MIT in 1984, with a dissertation on the microscopic theory of the dynamics of defects in semiconductors. He did postdoctoral work as a Bantrell Fellow and a joint MIT-IBM postdoc. He held a junior faculty appointment at the Weizmann Institute of Science in Israel. He became an associate professor of engineering at Boston University. And then, in 1997, he did something that surprised his colleagues. He left his tenured track position at a major research university to found an independent research institute devoted to complex systems, the New England Complex Systems Institute, NECIE, headquartered at 24 Mount Auburn Street in Cambridge, Massachusetts. Not affiliated with any university, not beholden to any department, free to cross disciplinary boundaries that academic departments exist to enforce. The son of a Holocaust survivor, a man whose father had lived through the most methodical ethnic violence in human history, who had watched his country of origin, Israel, struggle with exactly the kind of population boundary problems that the model describes, who had watched from across the Atlantic as Yugoslavia tore itself apart along lines that he would later show were geometrically predictable, built an equation that explains where ethnic violence happens. And I am telling you this not because it is interesting background. I am telling you because it connects directly to what the model means. When Bar-Yam says that the mathematics of ethnic violence is universal, that the specific identities of the groups do not matter, that the violence is a function of geometry rather than hatred. He is not making an academic point. He is making a point forged in the specific historical experience of a family that was nearly destroyed by ethnic violence. He is saying that what happened to his father's community in Krakow, what happened in Bosnia in 1995, what happened during the partition of India in 1947, and what is happening right now in places I will name shortly, are not separate phenomena with separate causes. They are the same phenomenon, the same equation, the same thermodynamic process. And the fact that we treat each one as a unique political event with unique political causes is not just intellectually wrong. It is dangerous because it means we keep being surprised by the same fire every time it breaks out in a different building, because we keep studying the match instead of the fuel. On May 7th, 2020, in the middle of the COVID-19 pandemic, Yaneer Bar-Yam wrote on Twitter, "I have lost my mother to COVID." Miriam Bar-Yam, the Harvard-educated developmental psychologist who had shaped her son's moral conscience, who had taught him that he did not have to feel that he was better than others, who had raised him in a household haunted by one genocide and devoted to preventing the next one, died of a virus that the institutions Bar-Yam had spent decades trying to influence were too slow to contain. He had warned them. He had founded endcoronavirus.org in February of 2020, months before most governments took the pandemic seriously. He had published op-eds, drafted petitions, modeled infection curves. The institutions moved too slowly, as they always do. There is a pattern here, and the pattern has nothing to do with viruses. Bar-Yam's model tells you where an empire will fragment. It draws the lines, but it does not tell you when. For that, you need a different mathematician, a different set of equations, and a different kind of biographical tragedy. Peter Valentinovich Turchin was born on May 22, 1957, in Obninsk, a small city about 100 kilometers southwest of Moscow. Obninsk was not an ordinary Soviet city. It was a closed scientific town, one of the handful of places in the Soviet Union where nuclear research was conducted. Turchin's father, Valentin Fyodorovich Turchin, was a physicist who had been trained at Moscow University and worked at the Institute for Theoretical and Experimental Physics. But Valentin was not just a physicist. He was a dissident. In 1970, he published The Phenomenon of Science, a grand cybernetic theory of universal evolution that drew the attention and suspicion of the Soviet authorities. He founded a Moscow chapter of Amnesty International. He corresponded with Andrei Sakharov. He signed open letters calling for democratic reforms. By the mid-1970s, the Brezhnev regime had decided to clean house. Solzhenitsyn was expelled in 1974. Other dissidents were imprisoned or sent to psychiatric facilities. Valentin Turchin was put under pressure to leave. In 1977, when Peter was 20 years old and enrolled at Moscow State University's Faculty of Biology, the Turchin family was expelled from the Soviet Union. Think about what that means for the man Peter Turchin would become. He watched an empire suppress his father for telling uncomfortable truths. He watched the mechanisms of institutional coercion, the career threats, the surveillance, the slow strangling of dissent through professional exclusion rather than dramatic persecution. And then, years later, he watched that same empire collapse. He returned to Moscow in the winter of 1992 and saw what a social collapse looks like. Passed out drunks on the streets, charred car wrecks left over from assassinations, collapsing infrastructure, the complete disintegration of the social order he had grown up in. Peter Turchin had seen the before and the after, the stability and the collapse, And as a trained population biologist, someone who had spent his career studying how populations of beetles and butterflies and deer rise and crash in cyclical waves, he recognized something that historians did not want to hear. The collapse was not unique. It was not a one-time event caused by a specific set of political circumstances. It was a cycle, and cycles can be modeled mathematically. In the late 1990s, Turchin did something that his colleagues in the biology department at the University of Connecticut considered somewhere between eccentric and delusional. He started applying the mathematical tools of population ecology, the differential equations, the time series analysis, the predator-prey models, to historical data, not data about beetles. Data about empires. He collected records of political assassinations, riots, lynchings, and civil wars going back centuries. He compiled wage data, population data, economic data, and elite overproduction data for medieval and early modern states. He published Historical Dynamics with Princeton University Press. In 2003, he published War and Peace and War in 2006, which introduced his concept of asabiyyah, borrowed from the 14th century Arab historian Ibn Khaldun, meaning the social cohesion that allows groups to form empires and whose decay causes those empires to disintegrate. And then, on July 3rd, 2008, Nature published an essay that changed everything. Volume 454, pages 34 through 35. Peter Turchin, Arise, Chi Dynamics. The essay opens with a line that should be carved into the wall of every history department on Earth. What caused the collapse of the Roman Empire? More than 200 explanations have been proposed, but there is no consensus about which explanations are plausible and which should be rejected. This situation is as risible as if, in physics, phlogiston theory and thermodynamics coexisted on equal terms. That is not a diplomatic sentence. That is a physicist, or rather a biologist trained in the mathematical methods of physics, walking into a room full of historians and telling them that their entire field is pre-scientific, that they have 212 explanations for the same event because they do not have a theory, that they have data without models and models without tests, and that the result is a discipline that cannot distinguish between correct and incorrect explanations because it has never established the mathematical framework necessary to do so. The essay calls for a new discipline, Cliodynamics, named after Clio, the Greek muse of history, a science, in the physics sense of the word, of historical dynamics, a field that would develop mathematical models of social processes, test them against historical data, and make falsifiable predictions about the future. The response from the historical establishment was approximately what you would expect. Many historians dismissed Turchin as a reductionist who did not understand the complexity of human societies. They accused him of physics envy. They pointed out that he held no degree in history. They said that human societies cannot be reduced to equations. Turchin's response was to ignore them and produce the equations. In 2009, he and Sergei Nefedov published Secular Cycles with Princeton University Press. The book analyzed 4 historical case studies in detail: the Plantagenet and Tudor-Stuart periods in England, the Capetian and Valois periods in France, the Muscovite and Romanov periods in Russia, and the Roman Republic through the Principate. For each case, they built a mathematical model based on what they called structural demographic theory. The model has 3 main variables: population dynamics, including carrying capacity and real wages; elite dynamics, including the number of elite aspirants versus the number of elite positions available; and state fiscal health, including revenue, expenditure, and debt. The model generates cycles, not because cycles are assumed, because they emerge naturally from the dynamics. The mechanism is this. During an integrative phase, population grows, the economy expands, real wages are relatively high, there are enough elite positions for elite aspirants, and the state is fiscally sound. This is the rise of the empire. But population growth eventually outstrips economic growth. Real wages begin to stagnate. The economy slows. And yet the elite class continues to grow because elite status is partly hereditary, partly educational, and the pipeline of elite aspirants does not respond quickly to economic conditions. So you get what Turchin calls elite overproduction. Too many people who consider themselves members of the ruling class for the number of ruling class positions available. Lawyers who cannot find partnerships. Nobles without fiefs. Degree holders without jobs that match their expectations. When elite overproduction reaches a critical threshold, competition within the elite intensifies. Factions form. Political polarization increases. The state's fiscal position deteriorates because the competing elite factions extract resources while blocking each other's policies. And then the disintegrative phase begins. Civil war, state collapse, population crash. A dark age, sometimes lasting decades, sometimes lasting centuries, until the cycle resets. The cycle length, across all 4 case studies and across a broader database of agrarian empires, is roughly 200 to 300 years, with a secondary, fathers and sons, oscillation of roughly 50 years embedded within it. These numbers are not asserted, they are measured, and they are consistent across civilizations that had no contact with each other. But Turchin did not just model the past. He did something that historians almost never do, and that scientists are supposed to do as a matter of professional obligation. He made a prediction. In February of 2010, Nature asked several scientists about their forecasts for the coming decade. Turchin submitted his. Nature published it. Volume 4, 63, page 608. Peter Turchin, Political instability may be a contributor in the coming decade. The key passage reads, quantitative historical analysis reveals that complex human societies are affected by recurrent and predictable waves of political instability. He identified several structural demographic indicators in the United States that had all passed their inflection points in the 1970s, stagnating or declining real wages, a growing gap between rich and poor, overproduction of young graduates with advanced degrees, exploding public debt. His model predicted that the United States would enter a period of major political instability peaking around 2020. He made this prediction in February of 2010, a full decade before 2020, before Trump, before the pandemic, before the murder of George Floyd, before the January 6th Capitol insurrection, before any of it. They had no reason to believe I was not crazy. Turchin told Time magazine in June of 2020, as American cities burned, people did not understand that I was making scientific predictions, not prophecies. The distinction matters. A prophecy is a claim about a specific event. Predictions in the scientific sense are claims about patterns, trajectories, and probabilities. Turchin did not predict COVID-19. He did not predict Donald Trump. He did not predict George Floyd's murder. He predicted that the structural conditions in the United States, conditions measurable with data going back to the 1970s, would produce instability in the 2020s. And they did. In 2020, Turchin and Andrei Korotiev published a retrospective assessment of the prediction, the 2010 structural demographic forecast for the 2010 to 2020 decade. published in PILO S1. They used the cross-national time series data archive to evaluate their prediction against actual instability data for the United States, the United Kingdom, and several major Western European countries. The prediction held. The political stress indicator, which had been strongly correlated with socio-political instability in the historical record, had risen exactly as the model forecast. Now here is where Bar-Yam's model and Turchin's model converge, and the convergence is what makes this story genuinely frightening rather than merely academic. Bar-Yam tells you where. The spatial geometry of population distribution determines the fault lines along which an empire fragments. Turchin tells you when. The structural demographic cycle determines the timing of the fragmentation. And when you overlay the two models, when you combine the where and the when, you get something that no single discipline has ever produced. A comprehensive, quantitative, testable theory of imperial collapse, where Bar-Yam draws the lines, Turchin draws the timeline. Where Bar-Yam shows you the fault lines in the census, Turchin shows you the pressures building in the economy, the elite, and the state budget. Where Bar-Yam's equation comes from condensed matter physics, Turchin's comes from population ecology. Different mathematics, different metaphors, same conclusion. Empires do not collapse because of bad leaders or bad luck. They collapse because mathematical pressures build along geometric fault lines until the system crosses a threshold and phase separates. And this has happened with the same patterns across every documented civilization in human history. Let me walk you through a few of them because the repetition is the point. The repetition is what makes it feel like a law rather than a coincidence. The Austro-Hungarian Empire. At its peak, it governed 51 million people across 678,000 square kilometers of Central Europe. 12 major ethnic groups: Germans, Hungarians, Czechs, Slovaks, Poles, Ukrainians, Romanians, Croats, Serbs, Slovenes, Italians, and Bosniaks. The 1910 census is a masterpiece of administrative detail. And when you look at the ethnic map, what you see is patches. Large, homogeneous patches of Hungarians in the central plain. Large, homogeneous patches of Germans in Austria and the Sudetenland. And then, at the margins, in Transylvania, in Bosnia, in the Czech-German borderlands, patches at exactly the characteristic length, 20 to 60 kilometers. Contested zones. When the empire dissolved in 1918, it fragmented along the boundaries of those patches. Czechoslovakia was the Czech and Slovak patches combined. Yugoslavia was the South Slav patches combined. Romania absorbed the Romanian patch of Transylvania. The rump of Austria was the German patch. The rump of Hungary was the Hungarian patch. The borders of the successor states traced the ethnic boundaries of the 1910 census with remarkable precision. Not perfect precision, because political negotiations at Versailles imposed some distortions, but the correspondence between census map and political map is unmistakable. The Ottoman Empire, at its administrative height under Suleiman the Magnificent in the 16th century, it governed roughly 25 million people across 5 million square kilometers, spanning 3 continents. Its administrative system was organized around the millet. A religious community granted a degree of self-governance: the Muslim millet, the Greek Orthodox millet, the Armenian millet, the Jewish millet. Each millet had its own laws, its own courts, its own tax structure. The millets were, in Bar-Yam's framework, large homogeneous patches with clear administrative boundaries. The system was stable for centuries. When the Ottoman Empire began to contract in the 19th and early 20th centuries, it fragmented along the millet lines. Greece declared independence in 1829, separating the Greek Orthodox millet. The Arab-speaking Sunni territories became the British and French mandates after World War I. Iraq, Syria, Palestine, Transjordan, the Armenian millet, which occupied a patch of eastern Anatolia at exactly the wrong size, surrounded by Turkish-speaking Muslim populations, suffered the genocide of 1915. Between 600,000 and 1.5 million Armenians were killed. A patch at the characteristic length, surrounded by another group. The model does not even need to know the word genocide. The geometry is sufficient. The Soviet Union collapsed in 1991, the same year as the Yugoslav census. But the Soviet collapse was far less violent than the Yugoslav one, and Bar-Yam's model explains why. The Soviet administrative system, whatever its other failings, had drawn internal borders, the boundaries of the Soviet Socialist republics, along approximate ethnic lines. The Russian SFSR was predominantly Russian. The Ukrainian SSR was predominantly Ukrainian. The Georgian SSR was predominantly Georgian. These were not perfect ethnic boundaries, but they were good enough. Large, homogeneous patches with clear administrative borders. When the political structure collapsed, each republic already had a defined territory, a defined administration, and a defined identity. The phase separation occurred along pre-drawn lines, and in most cases, it occurred relatively peacefully. But not everywhere. There were exceptions, and the exceptions are exactly where the model predicts them. The Fergana Valley in Central Asia, where Stalin's borders cut directly across a patchwork of Uzbek, Tajik, and Kyrgyz communities, producing exactly the kind of intermediate-sized patches that the model identifies as unstable. In June of 1990, Kyrgyz and Uzbek communities fought in Osh, killing several hundred people. The Tajik Civil War from 1992 to 1997 killed between 50,000 and 100,000 people in a country of 5 million. In June of 2010, ethnic violence erupted again in Osh and Jalalabad, killing hundreds. An article in The Economist titled "Kyrgyzstan, Stalin's Latest Victims" noted that the violence followed ethnic lines drawn by Soviet-era administrative decisions. NECSI explicitly cited this article as confirmation of their model. Nagorno-Karabakh, an Armenian majority enclave inside Azerbaijan, a patch at the characteristic length, surrounded by a different group. War in 1988 to 1994. War again in 2020. War again in 2020. 3 ending in the complete expulsion of the Armenian population. Chechnya, a Muslim-majority region inside the Russian Federation. 2 wars, 1994 to 1999 to 2009. Combined death toll estimated between 50,000 and 200,000. Crimea and the Donbas. Russian-speaking populations on the eastern edge of Ukraine in patches at exactly the critical size. Annexed and invaded in 2014 and 2022. Every exception to the relatively peaceful Soviet dissolution, every zone of post-Soviet violence, appears at exactly the locations where the Bar-Yam model predicts instability, where the administrative borders were well aligned with the ethnic patches, peaceful transition, where they were not, violence. The model does not need to know about Yeltsin or Gorbachev, or the Soviet nuclear arsenal, or NATO expansion. It needs a census and an equation, and it gets the answer right. So now I need to address the question that should be making you angry. Because if what I have just described is real, if the spatial geometry of population distribution predicts the locations of ethnic violence with 90% accuracy in Yugoslavia and 99.8% accuracy in India, And if this was published in Science in 2007, then where is the policy response? Where is the UN report? Where is the NATO doctrine that incorporates this into peacekeeping strategy? Where is the State Department briefing that uses this model to identify the next Yugoslavia before the killing starts? The answer is nowhere. And the reason it is nowhere is a story about institutional failure that is almost as disturbing as the model itself. To understand why this work was ignored, you need to understand something about how academic disciplines function, not how they are supposed to function, in the idealized version where knowledge flows freely across boundaries and good ideas are adopted regardless of their origin, how they actually function. In practice, in the real world of tenure committees and grant panels and journal editorial boards and conference invitations, Bar-Yam's paper was published in Science. That is the highest possible signal of quality. A paper in Science is supposed to be read by everyone. It is supposed to generate attention, funding, and follow-up research. And it did generate some attention. MIT Technology Review covered it. National Geographic wrote about it. A few complexity science conferences discussed it. But within the discipline that should have cared most, political science, the response was muted, bordering on hostile. The reason is straightforward and unflattering. Bar-Yam is a physicist. His team were physicists and mathematicians. The paper was published in a science journal, not a political science journal. And the model uses physics equations, not the theories, methods, or frameworks that political scientists are trained in. When political scientists looked at this paper, they did not see a breakthrough. They saw an outsider invading their territory with tools they did not understand, making claims that implicitly diminished the value of everything they had spent their careers studying. This is not speculation. This is exactly what the Weidman-Toft critique revealed. The critique was technically legitimate, as I described earlier, but read between the lines and something else emerges. The concern was not just that the correlations might be inflated. The concern was that a physicist was claiming to solve a problem that political scientists had been working on for decades, using an approach that made their own approaches look obsolete. The critique was published in a political science journal. The response was published in the same journal. And then the conversation largely stopped. The political scientists went back to studying grievances, institutions, and leadership. The physicists went back to studying complex systems. The model sat in the literature like a loaded gun on a shelf that nobody owns. I keep coming back to a phrase that Bar-Yam uses in his writing. He says that the model demonstrates a phenomenon that is universal. That word, in physics, has a specific technical meaning. It means the mathematics does not depend on the microscopic details of the system. It applies regardless of which groups, which grievances, which history. And the reason political scientists resist this word, the reason they push back against the claim of universality, is that their entire discipline is built on the opposite assumption. Political science is built on the premise that details matter, that the specific history of Serbia is different from the specific history of India, and that understanding the violence in each case requires understanding those specific histories. Bar-Yam is saying no. He is saying that the specific histories are surface-level phenomena, that underneath the history, underneath the politics, underneath the ideology, there is a mathematical structure that is the same everywhere, and that mathematical structure predicts the violence better than all the political analysis combined. This is an extraordinary claim, and extraordinary claims require extraordinary evidence. Bar-Yam has provided extraordinary evidence. 0.89 in Yugoslavia, 0.998 in India, 0.95 in Switzerland, 3 independent test cases, 3 different regions, 3 different ethnic configurations, 3 different political systems, and the same model with the same equation producing correlations that would be publishable in any field. But the evidence does not matter if nobody with the power to act on it ever reads it. And that is the real scandal. Not that the model exists, not that it works, but that it works and nobody uses it. There is a man who came closer than anyone else to bridging the gap between the mathematical models and the policy world. And he did it not by simplifying the math, but by stating the implications in language that everyone could understand. His name was Samuel Phillips Huntington, and he published The Clash of Civilizations and the Remaking of World Order in 1996, 7 years after the fall of the Berlin Wall, 3 years after the Bosnian War began, 1 year after the Srebrenica massacre. Huntington was a political scientist at Harvard. Unlike Bar-Yam and Turchin, he came from within the discipline. He had the credentials, the position, and the audience. And his thesis was provocative enough to generate the kind of debate that academic models rarely achieve. He argued that the post-Cold War world would not be organized around ideology, as it had been during the Cold War, or around economics, as many liberal internationalists assumed. It would be organized around civilizations, 8 or 9 of them: Western, Orthodox, Islamic, Hindu, Cynic, Japanese, African, Latin American, Buddhist, and the fault lines of future conflict would run along the boundaries between these civilizations. Societies united by ideology or historical circumstance, but divided by civilization, either come apart, as did the Soviet Union, Yugoslavia, and Bosnia, or are subjected to intense strain, as is the case with Ukraine, Nigeria, Sudan, India, Sri Lanka, and many others. He published this in 1996. He named Ukraine. He named Yugoslavia. He named India. He named Sudan, which would split in 2 in 2011. And he described what Bar-Yam would later formalize mathematically, that the fault lines of fragmentation are not political. They are cultural. They follow the boundaries of identity, not the boundaries of ideology. And when an empire that straddles a civilizational boundary comes under pressure, it breaks along that boundary, not along some other line determined by economics or leadership. But Huntington's thesis had fatal weaknesses that Bar-Yam's model does not. Huntington's categories were subjective. He defined civilizations by a combination of religion, language, history, and culture. But the definitions were fuzzy and the boundaries were debatable. Critics pointed out that his classification of Ukraine and Russia as members of the same Orthodox Slavic civilization was contradicted spectacularly by the Russian invasion of Ukraine in 2022. His classification of sub-Saharan Africa as a single civilization ignored the massive diversity within the continent. His framework was, as Nick Danforth wrote in Foreign Policy as recently as June of 2025, too incoherent, confused, or mushy to meaningfully explain the fault lines of global conflict. Bar-Yam's model has none of these weaknesses. It does not require you to define civilizations. It does not require you to classify groups into fuzzy categories. It takes census data, applies a universal equation, and draws the lines. It does not care whether you call the fault lines civilizational or ethnic or linguistic or religious. It identifies the spatial geometry, period. Huntington provided the intuition, Bar-Yam provided the equation, and Turchin provided the timeline. 3 pieces of the same puzzle, published across 3 different disciplines, none of which talks to the other 2. This is the institutional failure that should make you angry. Not that the knowledge does not exist. It does. It has existed since 2007 at the latest. The institutional failure is that the knowledge is trapped in disciplinary silos. The physicists published in Science, the political scientist published with Simon & Schuster, the ecologist historian published in Nature, and the people who actually make decisions about borders and peacekeeping and refugee resettlement read none of them. I said earlier that there are 212 proposed explanations for the fall of the Roman Empire, and Turchin's opening line in his 2008 Nature essay compared this to a world where phlogiston theory and thermodynamics coexisted on equal terms. That comparison was not rhetorical. It was diagnostic. When a field has 212 explanations for the same event and no mechanism for eliminating incorrect ones, the field does not have a theory. It has a collection of stories, and stories, however well told, do not prevent the next collapse. Physics went through this transition 300 years ago. Before Newton, there were dozens of competing explanations for planetary motion. Epicycles, crystal spheres, angels pushing planets along their paths. Newton did not add a 213th explanation. He wrote an equation, and the equation made predictions, and the predictions were tested, and the wrong explanations were eliminated not by debate, but by data. That is what Turchin was calling for in 2008. And that is what Bar-Yam delivered in 2007. And the response from the disciplines that are supposed to prevent empires from fragmenting and populations from being slaughtered was, for the most part, silence. But here is where it gets worse, because the models do not just explain the past. They generate output when you feed them the present, and the output is not reassuring. Bar-Yam's team did not stop with Yugoslavia and India and Switzerland. They applied the model to active and potential conflict zones around the world. In 2012, Andreas Groh, Alexander Gard-Murray, and Yaneer Bar-Yam published a preprint analyzing Yemen. In 2016, Raphael Parens and Yaneer Bar-Yam published an analysis of Syria. In both cases, the model identified the zones of actual conflict with the same spatial precision it had demonstrated in Yugoslavia and India. The Syria analysis is particularly instructive because it was published after the civil war had already begun, making it a test of the model against known data. The model predicted the ethnic and sectarian fault lines of the conflict: Alawite coastal strip, Sunni Arab interior, Kurdish north, Druze south, using the same phase separation mathematics, and the predictions matched the actual front lines of the war. Bar-Yam's team went further. They proposed a Swissification strategy for Syria, suggesting that the only durable peace would come from drawing cantonal-style boundaries that aligned with the population patches, similar to what the Dayton Accords had done for Bosnia in 1995. That proposal was published in a NECSI report in September of 2013. Nobody in a position of power acted on it. The war continued for another decade. And then there is the output that nobody wants to discuss, because the model can be run on any country with census data and mixed populations, including the ones that have not yet fragmented. I am going to describe what the model says when you apply it to the modern world, and I want to be careful about how I do this, because there is a difference between what the model predicts and what will actually happen. The model identifies structural instability. It draws fault lines. It does not predict the timing of fragmentation with precision, though Turchin's cyclical models narrow the window, and it does not account for the possibility that institutional interventions, if applied correctly and at the right scale, can stabilize an unstable system. Switzerland is proof that this is possible. The Jura is proof that even Switzerland could not do it everywhere, and that the failure to do it produces exactly the kind of violence the model predicts. So when I say the model has been applied to current geopolitical situations, I am not saying that the following countries will collapse. I am saying that the mathematics identifies structural fault lines in these countries that are analogous to the fault lines that preceded the collapse of Yugoslavia, the partition of India, the dissolution of the Soviet Union, and the fragmentation of the Ottoman and Austro-Hungarian empires. What happens next depends on whether the people who make decisions about borders and governance understand the mathematics. And as I have spent the last hour describing, the evidence suggests they do not. Start with China. The Han Chinese majority constitutes approximately 92% of China's 1.4 billion people. Across most of eastern and central China, the population is ethnically homogeneous. The model predicts stability in these regions. Large, homogeneous patches with no contested zones. But in two regions, the situation is different. Xinjiang, in the far northwest, is home to the Uyghur population, a Turkic-speaking Muslim group that constitutes roughly 45% of the region's 26 million people. The Uyghurs are concentrated in the southern Tarim Basin, in patches that fall squarely within the characteristic length range. They are large enough to constitute a local majority in several prefectures, but small enough to be surrounded by Han-majority cities and military installations. Tibet presents a similar geometry. The Tibetan population dominates the Tibetan Autonomous Region, but the region's borders include significant Han migration corridors, and the surrounding provinces of Qinghai, Sichuan, and Gansu contain Tibetan minority communities at the characteristic length. Chinese policy has oscillated between two approaches that correspond directly to the two strategies the Bar-Yam model identifies for resolving instability. The first is forced integration, moving Han settlers into Xinjiang and Tibet, diluting the local population, pushing the system toward the well-mixed regime where no group dominates locally. The second is administrative autonomy, granting Xinjiang and Tibet special administrative status with a degree of self-governance, moving the system toward the well-separated regime with clear boundaries. The model says both strategies can work in principle. Full integration and full separation both produce stability. The problem, the one the model makes brutally clear, is the transition. If you are trying to integrate a population, you must push it all the way through the violence-prone intermediate regime. If you stop halfway, if you achieve partial mixing but not full mixing, you have not solved the problem. You have made it worse. You have created patches at exactly the characteristic length. And the Chinese government's campaign in Xinjiang, which has involved the mass detention of an estimated 1 million Uyghurs in what the government calls vocational education and training centers, and what human rights organizations call internment camps, can be understood through the lens of the Bar-Yam model as an attempt to push the population through the dangerous intermediate regime by force. The model does not tell you whether this is morally acceptable. It tells you the physics. And the physics says that if the forced integration campaign succeeds completely, the resulting fully mixed population will be stable. But if it fails, if it achieves only partial mixing, if the Uyghur population retains patches at the characteristic length but is now more resentful and more radicalized, the resulting configuration is more dangerous than the one that existed before the campaign began. The European Union presents a different set of fault lines, but the same underlying mathematics. The EU is an experiment in maintaining political unity across linguistic, cultural, and ethnic boundaries without either full integration or full separation. It is, in a sense, an attempt to solve the Bar-Yam problem institutionally rather than geographically. And the stresses that have emerged over the past 2 decades, the Catalan independence movement in Spain, the Scottish independence referendum in 2014, the Flemish Walloon tension in Belgium, Brexit itself, can all be mapped onto the Bar-Yam framework. Catalonia is a linguistic and cultural patch of approximately 7.5 million people within a Spanish state of 47 million. The patch is at the characteristic length. It is large enough for Catalans to feel a distinct identity, large enough to dominate local public space, but embedded within a larger political structure that Catalans did not choose and that many wish to leave. The 2017 independence referendum, declared illegal by the Spanish government, and the subsequent imprisonment of Catalan leaders is exactly the kind of political crisis that the model predicts will occur at patch boundaries that lack clear administrative separation. Scotland's relationship with the United Kingdom follows the same pattern, but with a key difference. Scotland has a clear administrative boundary, the Scottish border. It has its own parliament, its own legal system, its own educational system. The Bar-Yam model would predict that these clear boundaries reduce the violence potential. And indeed, Scotland's independence movement has been entirely peaceful. The 2014 referendum was conducted without a single act of political violence. The administrative separation, the clear boundary, is doing exactly what the model says it should do. It is channeling the phase separation impulse through institutional mechanisms rather than through violence. Belgium is the most unstable European democracy by the Bar-Yam analysis. The linguistic boundary between Flemish-speaking Flanders and French-speaking Wallonia runs directly through the country. Brussels, the capital, is a French-speaking enclave inside Flemish territory. There is no clear administrative separation, despite decades of constitutional reform devolving power to linguistic communities. The patches are at exactly the characteristic length, and Belgium holds the world record for the longest time without a government. 541 days from June 2010 to December 2011, a record that is directly traceable to the inability of Flemish and Francophone parties to form a coalition across the linguistic fault line. But none of these European cases carry the same weight as the case that Turchin's model identifies as the most structurally unstable major power in the Western world, the United States. Turchin's 2010 prediction was not about a specific crisis. It was about a structural trajectory, and the structural indicators he identified have not improved since 2010. They have deteriorated. Real wages. In 1973, the average American worker's hourly compensation, adjusted for inflation, peaked. According to the Pew Research Center, which published an analysis on August 7, 2018, today's real average wage has about the same purchasing power it did in 1978. The Economic Policy Institute calculated that between 1973 and 2013, hourly compensation grew by 9.2%, while productivity grew by 74.4%. The gap between what American workers produce and what they are paid has been widening for 50 years. That is not a political opinion. That is a measured economic fact. Elite overproduction. The number of Americans with bachelor's degrees has roughly tripled since 1970. The number with graduate degrees has increased even faster. But the number of elite positions, the jobs that pay enough and carry enough status to satisfy people who were educated to expect elite outcomes, has not kept pace. The result is a growing population of credentialed, ambitious, frustrated people who cannot achieve the status their education led them to expect. Turchin argues, with data, that this is the single most dangerous indicator of political instability. It was true in late Republican Rome, where too many senators competed for too few consulships. It was true in pre-revolutionary France, where too many nobles competed for too few court positions. And it is true in the United States today, where too many law school graduates compete for too few partnerships, Too many PhD holders compete for too few tenure-track positions, and too many ambitious young people compete for too few slots in the increasingly narrow corridor of economic success. State fiscal health. United States federal debt has risen from approximately 36% of GDP in 1970 to over 120% of GDP today. The interest on the debt alone now exceeds the entire defense budget. The state's ability to respond to crises, to invest in infrastructure, to provide the kinds of services that maintain social cohesion, is being consumed by the cost of servicing debt accumulated during the disintegrative phase. Political polarization. The data on this is unambiguous. The distance between the median Democrat and the median Republican in Congress, as measured by voting records, has been increasing steadily since the 1970s and is now at its highest level since the Reconstruction era following the Civil War. Gerrymandering has created congressional districts that are themselves patches at the characteristic length, homogeneous enough to feel owned by one party, but embedded in a national political structure that is contested. And here is where Bar-Yam's spatial model meets Turchin's temporal model on the specific geography of the United States. The American political map is not random. It has a very specific spatial structure. Dense, diverse urban centers surrounded by vast, more homogeneous rural territories. The urban-rural divide in the United States is not just political. It is demographic, economic, and cultural. And the patches are at exactly the wrong size. Urban counties are large enough to feel like they constitute a distinct political community. Rural regions are large enough to feel the same way, but they are interleaved at a scale that the Bar-Yam model identifies as unstable. They share a state government, a federal government, a tax system, and a set of laws, but they increasingly do not share values, information sources, economic interests, or cultural identities. Turchin did not predict that the United States would collapse. He predicted that it would enter a period of instability comparable to the 1860s or the 1920s, driven by the same structural demographic forces that have produced instability in every agrarian and industrial society in the historical database when the same indicators aligned. And the question of whether the United States will pass through this period intact, the way it passed through the 1860s, with the Union preserved but at the cost of 600,000 lives, or whether it will fragment, the way Yugoslavia fragmented, the way the Soviet Union fragmented, the way every other empire in the database eventually fragmented, is not a question that the model answers definitively. What the model says is this: the structural conditions are present, the pressures are building, the fault lines are drawn, and the mathematics of phase separation is indifferent to American exceptionalism. I want to go back to something Bar-Yam said about universality, because universality is not just a technical term. It is a philosophical claim. And the philosophical claim is this: the specific identity of the groups does not matter. The model does not care if the groups are Serbs and Bosniaks, or Hindus and Muslims, or French and German, or Democrats and Republicans. The model cares about one thing: spatial distribution, patch size, boundary clarity. That is it. And if that is true, then the comforting story that Americans tell themselves that we are different, that the American experiment in diversity is qualitatively distinct from the failed experiments of Yugoslavia and Austria-Hungary and the Soviet Union, is not supported by the mathematics. The mathematics says the experiment succeeds or fails based on geometry, on whether the patches are at the characteristic length, on whether the boundaries are clear or contested, on whether the system is fully mixed, fully separated, or in the dangerous intermediate regime. And the American system, right now, in this moment, is in the intermediate regime, not fully mixed, because the political and cultural differences between urban and rural America are too large and too spatialized for genuine integration, not fully separated because the administrative boundaries, state lines, congressional districts do not align cleanly with the demographic and cultural patches. The fault lines exist. The patches are at the characteristic length. The boundaries are contested. I still do not know exactly what to do with this information. I have been reading about it for weeks, and I am not sure the correct response is reassurance or alarm. What I am sure of is that the information exists, that it has been sitting in peer-reviewed journals since 2007, that it has been validated against historical data from multiple countries and multiple centuries, and that the people whose job it is to prevent the next Yugoslavia have largely not read it. And that silence, that institutional silence, is itself a data point, because the model predicts that institutions resist uncomfortable information in exactly the same way they have always resisted it, not through conspiracy, not through deliberate suppression, through the quiet, decentralized process of people in comfortable positions declining to engage with findings that, if taken seriously, would require them to rethink everything they believe about how the world works. First, the finding is impossible. Then when someone demonstrates it, the finding is trivial. The one thing the finding can never be is important. I want to go deeper on the Roman case for a moment, because it illustrates something that neither Bar-Yam nor Turchin says explicitly, but that emerges unmistakably from the combined framework. And that is the idea that the fragmentation of an empire is not a single event. It is a process, a thermodynamic process that can take centuries and that passes through predictable phases, each one making the next one inevitable. Turchin and Nefedov devote an entire section of secular cycles to Rome. Their analysis covers the period from roughly the middle of the 2nd century BCE to the 5th century CE, a span of about 600 years. And what they find is not one cycle, but two, nested inside each other. The first cycle begins with the crisis of the Roman Republic. From roughly 133 BCE, when Tiberius Gracchus was murdered by a mob of senators for proposing land reform, to the civil wars of Marius and Sulla, Caesar and Pompey, Octavian and Antony, to the establishment of the Principate under Augustus in 27 BCE. This is a classic disintegrative phase. Elite overproduction, the surplus of Roman senators and equestrians competing for a fixed number of magistracies. Popular immiseration, the replacement of small farmers by slave-worked latifundia. State fiscal crisis, the inability of the Republic's tax system to fund its military commitments. Political violence, escalating from isolated murders to full-scale civil war. The Republic did not fall because of any single event. It fell because every structural indicator was in the red simultaneously. Augustus solved the crisis temporarily by concentrating power. He reduced elite competition by making the emperor the sole source of patronage. He stabilized state finances through the annexation of Egypt and the reform of provincial administration. He reduced popular immiseration through land distribution to veterans and grain distribution to the urban poor. The system stabilized. The Principate entered an integrative phase. Population grew. The economy expanded. The Pax Romana lasted roughly 2 centuries. But the second cycle was already beginning. Population growth outstripped economic growth. The silver content of Roman coinage was debased, from nearly pure silver under Augustus to less than 5% silver by the late 3rd century, an inflation crisis that destroyed savings and commerce. Elite overproduction returned, as provincial elites and military commanders competed for the imperial throne. Between 235 and 284 CE, a period of 50 years, Rome had over 26 emperors. Most of them died violently. The state's fiscal position collapsed. The frontiers were breached simultaneously by Germanic tribes in the north and the Sassanid Persians in the east. Diocletian's reforms in 284 temporarily stabilized the system by splitting the empire into eastern and western halves, with 4 co-emperors, the Tetrarchy. But this was itself a form of phase separation. The eastern half, with its Greek-speaking population concentrated in a large homogeneous patch centered on Constantinople, stabilized. It survived for another 1,000 years as the Byzantine Empire. The western half, with its patchwork of Latin-speaking Roman populations, Germanic settlers, and provincial identities at the characteristic length, continued to fragment. By 476, the last Western emperor had been deposed, and the Western territory had separated into Germanic successor kingdoms whose borders roughly followed the ethnic and linguistic patches that had been forming for centuries. The Bar-Yam model and the Turchin model are not competing explanations. They are 2 lenses focused on the same object. Turchin explains the temporal dynamics, why the crisis happens, when it happens. The structural demographic indicators reach critical thresholds. The system enters the disintegrative phase, and Bar-Yam explains the spatial dynamics, where the fracture lines appear along the patch boundaries, at the characteristic length. And the Roman case demonstrates something that should be deeply alarming about the current moment. The disintegrative trend can begin long before anyone notices. Turchin's indicators for Rome began deteriorating in the mid-2nd century CE, roughly a century before the crisis of the 3rd century that historians traditionally identify as the beginning of the decline. The patches that would become the successor kingdoms were forming centuries before the political dissolution. The phase separation was in progress. The Lifshitz-Sliozov equation was running. The patches were growing, and the people living inside the system, the Roman citizens going about their daily lives, had no idea that the ground beneath their feet was slowly reorganizing itself into the borders of future nations. I bring this up because the same process is occurring right now, in real time, in countries that consider themselves stable, and the process is invisible at the timescale of daily experience. You cannot see the patches forming by watching the news. You cannot see the boundaries hardening by reading the polls. You can only see it in the census data, in the slow, decadal shift of populations toward geographic self-sorting, in the decline of mixed neighborhoods and the growth of homogeneous ones, in the data that shows Americans increasingly living near, working near, and socializing near people who share their political and cultural identities, in the data that shows Catalan speakers concentrating in Catalonia, Flemish speakers concentrating in Flanders, Uyghurs concentrating in the Tarim Basin. The cube root of time, invisible at the scale of years, unmistakable at the scale of decades, irreversible at the scale of centuries. And the equation does not have an opinion about whether this is good or bad. It does not have a preference for unity or fragmentation. It does not care about your national anthem or your constitution or your sense of shared identity. It describes a thermodynamic process, a process that has been running in one form or another since the first time 2 groups of humans who identified differently from each other occupied the same territory. The process is not political. It is not cultural. It is not even social in the way that social scientists use the word. It is mathematical. It is a consequence of the same preferences that Thomas Schelling demonstrated with pennies on a checkerboard in 1971. The mild, reasonable, almost universal preference for not being a complete stranger in your own neighborhood. The preference that, in isolation, is so benign it is almost invisible. But that, in aggregate, across millions of people and decades of time, produces the fault lines along which civilizations break. You are part of this process, not as a conscious actor, not as someone who chose to contribute to the phase separation of your society, but as a data point, a cell on the grid, an agent in the lattice. The equation includes you. Your preferences, your choices about where to live and who to associate with, and which neighborhood feels like home, are inputs to the Cahn-Hilliard equation, whether you know it or not. And the output of the equation is the map that draws the fault lines, the map that a physicist in Cambridge, Massachusetts could generate from your country's census data using an equation originally designed for metal alloys. The map that nobody in power is looking at. The map that was accurate to 90% in Yugoslavia and 99.8% in India and 95% in Switzerland. The map that is being drawn right now. By you, by everyone, by the mathematics of phase separation, operating on the spatial distribution of human preferences across a shared territory. And the people who should be reading it are not. There is something else about this story that I have been holding back, and I think it is time to say it directly. When I described the Cahn-Hilliard equation earlier, I said that the mathematics of phase separation is universal, that it applies to oil and water, to metal alloys, to population distributions. But I left out the most disturbing part of the analogy, the part that separates this from a clever academic model and turns it into something that should genuinely change how you think about civilizations and the one you are living in right now. In a binary alloy, phase separation is thermodynamically inevitable. If two metals do not mix well at a given temperature, they will separate. The question is not whether, it is when. You can delay the separation by keeping the temperature high, by pumping energy into the system. But the moment you stop pumping energy, the moment the external force that maintains the mixed state is removed, the system begins to phase separate. And the separation proceeds according to the Lifshitz-Lyasov law. The patches grow as the cube root of time, slowly at first, then faster, and the process does not reverse spontaneously. You cannot stir the alloy back together once it has begun to separate. You can only remelt it, which requires enormous energy input, or you can wait for the separation to complete, at which point you have two distinct phases with a clear boundary between them. Think about what that means when the agents are not atoms, but people. In Yugoslavia, the external force that maintained the mixed state was the Tito regime, the policy of brotherhood and unity, the suppression of nationalist sentiment, the economic redistribution from wealthier republics to poorer ones, the security services that monitored and punished expressions of ethnic separatism. This was the energy being pumped into the system to keep it mixed, and it worked in the sense that overt ethnic violence was suppressed for the 45 years between the end of World War II and the collapse of communism. But the preferences that drive phase separation, the mild, Schelling-type preference for being near people who share your language and your customs and your religion, never went away. They were suppressed, not eliminated. And the moment the external force was removed, the moment Tito died in 1980, and the communist system that had maintained the mixing collapsed over the following decade, the phase separation resumed, as the mathematics said it would. In the Soviet Union, the external force was the Communist Party, the security services, the planned economy, the Russian language educational system, the entire apparatus of Soviet power that held 15 republics and dozens of ethnic groups in a single political structure. When that apparatus collapsed in 1991, The system phase separated along the fault lines that the census data had already drawn. In the Austro-Hungarian Empire, the external force was the Habsburg monarchy, the imperial bureaucracy, the army, the personal prestige of Emperor Franz Joseph, who reigned from 1848 to 1916. When Franz Joseph died and the empire was defeated in World War I, the external force was removed. Phase separation occurred within months. In the Ottoman Empire, the external force was the Sultan, the millet system, the Ottoman military, the administrative structure that had governed a multi-ethnic empire for 6 centuries. When that structure weakened in the 19th century and collapsed in the early 20th, phase separation occurred along the millet boundaries. Do you see the pattern? Because the pattern is not political, it is thermodynamic. Every multi-ethnic empire in history can be understood as a forced mixture maintained in a non-equilibrium state by an external energy input. The energy input takes different forms depending on the era: military force, administrative bureaucracy, economic redistribution, ideological coercion, charismatic leadership. But the function is the same. It maintains the mixture. It prevents the phase separation that the underlying preferences would otherwise produce. And here is the conclusion that follows inevitably from the physics. Every forced mixture, in the absence of sufficient external energy, will phase separate. The question is not whether, it is when. And the lines along which the separation occurs are not determined by the politics of the moment. They are determined by the spatial distribution of the populations at the time of the separation. They are drawn in the census before the first shot is fired. I want to be honest about something here, because I think the audience deserves honesty more than comfort. I do not know whether the model is completely right. No model is completely right. The map is not the territory. Phase separation in metals is governed by quantum mechanics and electrostatic forces that have precise mathematical descriptions. Phase separation in human populations is governed by preferences and decisions and social pressures that are far messier and far less well understood. The analogy between atoms and people is compelling, but it is not perfect. And yet, the correlations are what they are: 0.89, 0.998, 0.95. These are not vague resemblances. These are the kind of predictive accuracy that physicists achieve when they are measuring real phenomena, not when they are constructing metaphors. Either the model is capturing something real about how human populations behave in aggregate, or the correlations are the most remarkable coincidence in the history of social science. I know which one I believe, and I suspect the physicists know too. Because after the 2007 paper was published, after the critiques were addressed, after the Switzerland data confirmed the predictions, NECSI continued to apply the model, not just to academic test cases, to active conflicts, to policy recommendations, to places where people were dying. In 2013, Bar-Yam and Casey Friedman published a NECSI report titled Swissification, Syria's Best Hope for Peace. The report proposed drawing cantonal boundaries in Syria that would align with the ethnic and sectarian population distribution, creating autonomous zones for Alawites, Sunni Arabs, Kurds, Druze, and Christians. The proposal was based directly on the mathematics. Draw the boundaries at the right scale, align them with the patches, and the propensity to violence drops the same way it drops in Switzerland when you add the cantonal borders, from 57% to 20%. Nobody in power implemented this recommendation. The Syrian civil war continued from 2011 to, depending on how you date its end, 2020 or beyond. Over 500,000 people died. 12 million were displaced. Half the country's housing stock was destroyed. An entire generation of Syrian children grew up without stable access to education, healthcare, or safety. And the model was sitting there the entire time, published, available, mathematically precise, offering a solution that the data said would work, not a guaranteed solution, not a painless solution, but a solution grounded in the same mathematics that explained Yugoslavia and predicted Switzerland, a solution that treated the spatial geometry of the population as the fundamental variable rather than the latest round of peace negotiations between factions that the geometry had already determined would fight. In 2012, Groves, Gard-Murray, and Bar-Yam published an analysis of Yemen that predicted the geographic locations of conflict based on the ethnic and tribal distribution of the population. Yemen's civil war began in 2014. The front lines of the conflict followed the fault lines the model had drawn 2 years earlier. I sometimes wonder what the body count would be if the people who make decisions about war and peace could read a phase diagram the way they can read a polling forecast. The model has been available for almost 20 years. It has been validated on multiple continents. It has been published in the most prestigious scientific journals on Earth, and the total number of peace agreements, military interventions, or border adjustments that have been informed by it, as far as I can determine from publicly available information, is zero. Zero. Think about how many people died in Syria. Think about how many people died in Yemen. Think about how many people will die in the next conflict that erupts along fault lines that the model could identify today. Using census data that already exists, using an equation that is already published, using mathematics that has already been validated. And think about the fact that the people whose job it is to prevent that killing, the diplomats, the generals, the policy analysts, the heads of state, do not know this model exists. Or if they know it exists, they do not understand it. Or if they understand it, they do not believe it. Or if they believe it, they do not have the political will to act on it, because acting on it would mean admitting that the spatial distribution of populations is more predictive of violence than all the diplomacy, all the treaties, all the peacekeeping operations, all the nation-building exercises that consume billions of dollars and thousands of lives. And that is an admission that no institution is prepared to make. Let me return to Peter Turchin now, because his story has one more layer that connects to everything I have described, and the connection is almost too perfect. Turchin's father, Valentin, was a physicist who became a dissident. He studied the systems of power that governed the Soviet Union and concluded that they were unstable. He said so publicly. He was expelled for saying it. The Soviet Union collapsed 14 years after the Turchin family was forced to leave. Peter Turchin became a biologist who studied population cycles in nature. He recognized that the same mathematical patterns appeared in human history. He said so publicly. He was dismissed by historians who said he did not understand the complexity of human societies. 14 years after he made his prediction about American instability in 2010, the United States experienced exactly the kind of crisis he had forecast. Father and son, two different empires, two different disciplines, the same pattern. The outsider identifies the instability, the institution rejects the warning, the instability arrives on schedule. And here is the part that Turchin himself has noted in a blog post written on the 40th anniversary of his family's expulsion from the Soviet Union. He writes about returning to Moscow in the winter of 1992 and seeing what a social collapse looks like. The drunks on the streets, the charred car wrecks, the collapsing infrastructure. And he writes, "Now, in retrospect, we know that this appearance was deceptive. The disintegrative trend had already set in before anyone could see it, before anyone but a mathematician with the right equations could measure it. The system was already past the point of no return, and the people living inside the system had no idea. That is the sentence that haunts me, because Turchin's model says the same thing about the present. The disintegrative trend has already set in. The structural demographic indicators have been deteriorating since the 1970s. The elite overproduction is measurable. The wage stagnation is measurable. The state fiscal deterioration is measurable. The political polarization is measurable. And the spatial distribution of the population, the patches, the fault lines, the patches at the characteristic length, is measurable. The data is there. It has been there for years, and the institutions that are supposed to respond to it are doing what institutions have always done when confronted with uncomfortable mathematical truths. They are ignoring it, not because they are evil, not because they are conspiring, because the mathematics describes a phenomenon that is outside their conceptual framework, because the solution the mathematics implies, redrawing boundaries, restructuring governance to match the spatial distribution of populations, admitting that the current configuration is thermodynamically unstable, requires a kind of political honesty that no government in history has been willing to offer before the crisis forced it. The Dayton Accords, which ended the Bosnian War, are the closest thing to a Bar-Yam solution that has ever been implemented. The Accords divided Bosnia into two entities, the Federation of Bosnia and Herzegovina and Republika Srpska, with boundaries that roughly align with the ethnic patches. The model predicts that this configuration is stable, and in the 3 decades since Dayton, despite enormous political tensions, despite corruption and dysfunction, and mutual distrust, there has been no return to large-scale violence in Bosnia. The boundaries hold, because the boundaries match the patches, because the geometry is correct. Nobody designed the Dayton Accords using phase separation mathematics. The negotiators at Wright-Patterson Air Force Base in November of 1995 were not reading science. They were drawing lines on a map in the way that exhausted diplomats draw lines, through a combination of military facts on the ground, political pressure, and improvised compromise. But the lines they drew happened to correspond to the lines that the model would have drawn. And because of that correspondence, accidental or not, the peace has held. How many lives would be saved if the next Dayton were designed deliberately? If the negotiators had the model on the table next to the map? If the lines were drawn not by exhausted diplomats improvising at 3 a.m, but by an equation that has been validated across 100 years of data from 3 continents? I do not know the answer to that question, but I know that the equation exists, and I know that nobody is using it. There is one more thing I need to tell you, and it is the thing I have been building towards since the beginning. When I started this script, I said that the model was formalized around 2007 and 2008. That is true. Bar-Yam's paper in Science was September 2007. Turchin's manifesto in Nature was July 2008. But there is a deeper history, a history that makes the formalization feel less like a discovery and more like a confession. Because the observation that empires fragment along ethnic and cultural lines is not new, it is ancient. What is new is the equation, and the equation's existence changes the observation from a historical curiosity into a law. Ibn Khaldun, the 14th century Arab historian, described the cycle of empire rise and fall in his Muqaddimah, published in 1377. He called the force that binds a group together asabia, a word that Turchin borrowed directly for his own models. Asabia is group solidarity, group feeling, the willingness of individuals to sacrifice for the collective. Ibn Khaldun observed that nomadic groups on the frontier of civilizations had high asabiya because they were constantly under threat. They conquered sedentary empires whose asabiya had decayed through luxury and complacency. The conquerors built a new dynasty. Over 3 or 4 generations, the dynasty's asabiya decayed. A new frontier group with higher asabiya conquered them, and the cycle repeated. 650 years later, Turchin translated this observation into differential equations. And the equations generate cycles, not because Turchin forced them to, because the mathematics of nonlinear dynamics produces oscillations whenever a system has delayed feedback. The predator-prey equations of Lotka and Volterra produce oscillations. The structural demographic equations of Turchin and Nefedov produce oscillations. And the oscillations are not metaphors. They are measurable in the historical record. 2 to 3 century secular cycles with 50-year fathers and sons embedded within them. England, France, Russia, Rome, Egypt, China. The pattern repeats across civilizations that had no contact with each other. Ibn Khaldun saw the pattern. He described it in words. Turchin described it in equations. And the equations confirmed what the words had said. The cycle is real. The rise and fall of empires follows a mathematical trajectory. The trajectory is predictable, and the trajectory does not exempt any particular civilization from its logic. But the Bar-Yam model adds something that neither Ibn Khaldun nor Turchin fully captured. It adds the geometry. It answers a question that the cyclical models leave open. When an empire enters the disintegrative phase, when the asabiya has decayed, and the elite overproduction has reached its critical threshold, and the state's fiscal position has collapsed, and the system is ready to fragment, where does it break? The answer, as I have described, is that it breaks along the lines drawn by the spatial distribution of the population. The census map, the patch, boundaries, the zones where groups of different identities are interleaved at the characteristic length, the same lines every time. Not because history repeats itself, but because geometry repeats itself, because the mathematics of phase separation does not change with the century, or the continent, or the names of the groups involved. The equation is the same, whether the year is 1218, or 1918, or 2025. And I want you to understand the full weight of what that means, because it means that the fault lines along which your country, whatever country you live in, might one day fragment, are not being created by the politicians you are angry about. They are not being created by the media you blame. They are not being created by the social media algorithms you fear. Those things are accelerants. They are matches, but the fuel was there before the match was struck. The fuel is the spatial distribution of the population, the patches, the boundaries, the geometry. And the fuel has been accumulating for decades, for centuries in some cases. It accumulates the way metal alloys phase separate, slowly, the cube root of time, a process so gradual that it is invisible on the timescale of a human life. You cannot see the patches forming. You cannot feel the boundaries hardening, but the census captures it, and the equation reads the census, and the equation draws the lines. Let me tell you what happened in Moutier, because it is a small story that contains the entire argument. Moutier is a town of about 7,500 people in the Jura Mountains of northwestern Switzerland. It is one of the communes that sits directly on the linguistic fault line between French-speaking and German-speaking Switzerland. When the canton of Jura was created in 1979, Moutier voted to stay with the canton of Bern 3 times, in 1974, in 1975, and again in subsequent votes. The town chose Bern, but each time the margin was narrow, and each time, the separatist minority, the French-speaking Catholics who wanted to join the new canton of Jura, felt that the result was illegitimate. The conflict simmered for decades. In 2017, Moutier held another referendum. This time, the town voted to leave Bern and join Jura by a margin of 137 votes out of about 4,500 cast. But the result was challenged. Irregularities were alleged. The canton of Bern's judicial authorities annulled the vote. The process dragged on for years. Finally, on June 18, 2017, a definitive vote was held. Moutier voted to transfer from the canton of Bern to the canton of Jura. The transfer is expected to take effect on January 1st, 2026. One town, 7,500 people, a linguistic fault line that has produced conflict for more than a century. A series of referendums spanning 50 years, and the conflict in 2025 is still not fully resolved. The administrative transfer has not yet taken effect. The boundary is still being redrawn. Now think about what the Bar-Yam model says this means. It means that even in Switzerland, the most stable, most democratic, most prosperous multi-ethnic society on earth, a single misaligned boundary at the characteristic length can produce a century of conflict. Not war, not genocide, but persistent, grinding, institutional conflict that consumes political energy and human patience for generations. And that the only resolution is the one the model predicts. Redraw the boundary. Align it with the patches. Correct the geometry. If it takes Switzerland a century to correct one boundary for one town of 7,500 people, how long will it take the rest of the world? I said at the beginning that the model was formalized around 2007 and 2008, and that it should have been front-page news. Let me revise that statement. The observation was made in 1377 by Ibn Khaldun. The mechanism was demonstrated in 1971 by Thomas Schelling. The equation was published in 1958 by John Cahn and Cahn-Hilliard. The application to ethnic violence was published in 2007 by May Lim, Richard Metzler, and Yaneer Bar-Yam. The temporal model was published in 2008 by Peter Turchin. The Swiss confirmation was published in 2014 by Rutherford et al. The prediction about American instability was made in 2010. Every piece of the puzzle has been available for at least a decade. Most of the pieces have been available for much longer, and the picture they form, when assembled, is this. Empires are not permanent structures. They are forced mixtures maintained in non-equilibrium states by external energy inputs. When the energy input declines, which it always does, because the energy input is itself subject to cyclical dynamics, the mixture phase separates. The separation follows fault lines determined by the spatial distribution of the population. Those fault lines can be identified in advance using census data and an equation from condensed matter physics. The timing of the separation can be estimated using structural demographic models calibrated against centuries of historical data. And the violence that accompanies the separation can be predicted and potentially prevented by drawing administrative boundaries that align with the population patches at the characteristic length. This is not a metaphor. It is not an analogy. It is a published, peer-reviewed, multiply-validated mathematical framework that explains the spatial and temporal dynamics of civilizational fragmentation across at least the past 2,000 years of human history. And the number of governments that have incorporated this framework into their strategic planning is, as far as anyone can tell, 0. The last census in Yugoslavia was taken in 1991. The killing started in 1992. The model that could have predicted where the killing would happen was not published until 2007, 16 years too late. But the mathematical framework it relies on, the Cahn-Hilliard equation, was published in 1958, 33 years before the census. The Schelling model was published in 1971, 20 years before the census. The physics was there, the mathematics was there. The only thing missing was someone willing to connect the dots. And by the time someone did, 100,000 people were dead and 2 million were refugees. Think about the next country that is going to fragment, the next census that contains a death map that nobody is reading, the next set of patches at the characteristic length, the next group of people who believe they are living in a stable state, because the forces maintaining the mixture have not yet weakened below the critical threshold. The mathematics says they exist. Right now, in multiple places on this planet, the census data is available. The equation is published. The fault lines can be drawn today, and nobody is drawing them because the people who have the power to act do not understand the physics, and the people who understand the physics do not have the power to act. Yaneer Bar-Yam was born to a Holocaust survivor who escaped the most systematic ethnic violence in human history. He built an equation that predicts where ethnic violence will occur, using the same mathematics that describes how oil separates from water. He published it in Science. He validated it across 3 continents. He proposed solutions for active conflicts in Syria and Yemen, and the institutions that are supposed to prevent ethnic violence treated his work the way institutions have always treated uncomfortable mathematics. They filed it, they critiqued it, they moved on. Peter Turchin was expelled from the Soviet Union for his father's dissent. He watched one empire collapse. He built equations that predict when empires enter the disintegrative phase. He published in Nature. He predicted American instability a decade before it arrived. And the response from the institutions that are supposed to maintain stability was the same response those institutions have given to every mathematical warning in human history. Polite interest, professional skepticism, no action. The pattern that Bar-Yam formalized is not just a pattern about how empires fragment. It is a pattern about how knowledge is handled by the institutions it threatens. The outsider identifies the instability. The institution rejects the warning. The instability arrives. And the census data from the next country that will fragment is sitting in a government office right now, in neat columns, filed and forgotten. A death map that nobody is reading, drawn in the same mathematics as oil and water, waiting for the external force to weaken below the critical threshold. And when it does, the phases will separate. The patches will harden, the boundaries will become front lines, and the historians will write 212 explanations for why it happened. The equation will still be sitting on page 1540 of Science, Volume 3, 17, Issue 5, 844, and nobody will have read it in time.